the automated plant watering system for ESET 462 control systems. The team is Rodolfo Arias, Bradley Brewington, Eric Carreto, Brant Essman, Jack Lance, Brian Ramirez, and Blake Trevino. What are we doing? So we are doing, like I said, an automated plant watering system. The problem is that about 50% of plant owners have their plants die due to forgetting to water them. It's a lot of effort, and sometimes you just forget. And so, on the other hand, you can also drown your plant by overwatering it. Certain plants have certain moisture level needs that they have. So what our system is doing is giving the user a way to specifically keep the moisture level of the soil at a set rate for the plants. So what we did to implement this was pretty much just a support spike setup. We used a Arduino to program the different analog inputs, a servo motor to control rotational actuation of a titration valve. This valve allowed for the control of the flow rate of the water that was being fed to it. The water is fed to the titration valve through a plastic tube that is connected to a water bottle, essentially, like a water reservoir. In the future, this could be used with, like, say, a hose. That way you always have constant pressure and unlimited water. A moisture sensor is planted within the pot. Our plant is a pot of dirt, but the moisture sensor is planted within the pot, and ideally under where the water is being dropped, just because in this case the soil was not very absorbent of water. The software we used, we mainly just used a program on the Arduino IDE, but I won't go into the specifics of that. And here is a video of our project working. The lessons learned in this project, we learned how to apply the analytical method to get the controller gain values for a control system. We learned how to develop a product from start to finish. That includes getting the idea all the way to the finalized product. We learned that testing should be implemented throughout the design process and not just at the end of the project. That's kind of where we fell short here. We tested at the very end, and it became kind of late to change some things. Whereas if we tested throughout the design, like, say, our gain values or how the mechanical setup might work, We waited till the end to fix those things or test them. It would have been better to test those throughout the time we were given. And then we also learned how to make controlled design selections based on a specific need. Like for example, we we had chosen certain gain values to over damp the system because we decided we don't want any sort of overshoot because we don't want to drown the plants. So, thank you. Howdy.